Okay, in this first video, we're going to talk about average speed and instantaneous speed. You're going to be able to calculate average speed from distance traveled in elapsed time, learn how to distinguish between average speed and instantaneous speed, and explain how we could estimate instantaneous speed. So here's the situation. We've got something moving in a straight line and just going in one direction, not turning around. So let's say I start here and I'm playing fetch with my dog and I throw the ball and my dog runs and gets to this point over here, which we'll say is 12.5 meters, and he does that in a clock time of 5.0 seconds. And here's the information in a table for his run. The time in the left column and the distance he's traveled in the rightmost column. Notice that we could also graph these and put them in a graph with distance traveled on the left-hand side and time on the bottom, distance on the y-axis, time on the x-axis. So if I plot that quickly, I've got he's at the start at point 0 at time 0. At 1 second, he's a half meter away. Then at 2 seconds, he's 2 meters away. 3 seconds, he's gone a distance of 4.5 meters. At 4 seconds, he's traveled 8 meters. And at 5 seconds, he's traveled 12.5 meters. And I can connect that with a smooth curve. And then I can ask, what's the average speed? So the average speed is just given by the distance that he's traveled divided by the time that he's taken to do that. So for example, if I ask what's his average speed over the whole 5 seconds, then I'm just going to take the total distance, which is 12.5 meters, and I'm going to divide that by 5.0 seconds, and this is going to be average speed, and I get 2.5 meters per second. Okay, I could also ask though, what's his average speed from 4 seconds to 5 seconds? So from 4 seconds to 5 seconds, he's gone 4.5 meters, 12.5 minus 8. So his average speed in that time interval is 4.5 meters divided by, that's only 1 second, and that's 4.5 meters per second. So you can see that his average speed over the whole 5 seconds and his average speed on this shorter time interval are not the same. And if you take a look at the graph, you can see that he's speeding up. So it makes sense that his average speed on the later time interval is faster than on the earlier time interval. Okay, so to define average speed is the rate, or how fast an object is covering distance. And we saw that you find that by just dividing the distance covered by the time. Whereas instantaneous speed, so average speed is that over a time interval. Instantaneous speed is the same thing, so I'm going to put these ditto marks here, but instead of over a time interval, it's actually at 1 instant in time. And that is actually often what we're more interested in figuring out, because this is what a speedometer shows. When you look at your speedometer on the car dashboard, it's showing you how fast you're going at that instant in time. But that gives us a bit of a problem, because remember that average speed was equal to distance divided by time. And if we're talking about speed at an instant, then the time is 0. And as you know, you can't divide by 0. So once you learn calculus in math class, you'll be able to do this exactly. But for now, we can just estimate it, and I'll show you how to do that now. Okay, so same data as in the previous example. I'm playing fetch with my dog, and we've got the same graph. And here I've got the same table of values, except notice that I've zoomed in on the time around 3 seconds, because I'm going to try and figure out the instantaneous speed at exactly 3 seconds. Now, I've got a stopwatch that's more precise than I had before. Now I've got 10,000ths of a second, and I've also got a ruler or something else to measure the distance traveled more precisely. And I'm zooming in on this time, and what I'm going to ask is, what's the average speed on this very small time interval? because the average speed on this very small time interval is going to be very close to the instantaneous speed at exactly 3 seconds, or at 3 seconds with this many decimal places, because there's just not enough time for the speed to change that much. I can't get the instantaneous speed exactly, but the smaller I make this time interval, the better the estimate I get. So I'm actually going to find the average speed on that time interval, and that is the distance traveled. So I haven't shown the subtraction in the previous examples, but let me show the subtraction now. It's 4.5003 meters minus 4.5000 meters. That's the distance traveled, which is in the numerator, and then the time elapsed is that 1/10,000th of a second. And those numbers actually work out quite well, right? It's 3/10,000ths of a second, 3/10,000ths of a meter, divided by 10,000th of a second, and the average speed over that time interval is therefore I'm going to call that 3.0 meters per second. That's the average speed over this very, very small time interval. Notice it's different to either of the answers we got before, and that's my estimate right now for the instantaneous speed, or what the speedometer, if I could put a speedometer on my dog, what the speedometer on him would be showing at 3 seconds. We'll talk in a later lesson about what that looks like on the graph, but notice for now that we're zooming in on that point. Okay, so in summary, what you've learned today is about average speed and instantaneous speed. You've learned that average speed is the rate at which distance is being covered, and so can be calculated by the distance traveled divided by the time elapsed. And you've also learned that you can estimate instantaneous speed by just looking at a very, very small time interval and doing the same calculation. All right, that's it for average speed and instantaneous speed. Thanks for watching. Time to practice.